Hello and welcome. This is going to be the homework help video for the last 3 pages of the packet that we started in class. This is the section that was left as the homework. Just going to jump right into it as soon as I get this thing working. All right. Answer the following questions related to points and linear graphs. Identify the point that lies in the line y equals 4 to the x plus 3. So this is where we're trying to verify which of these, like this, we know only one of these can be. So we'll just start going through them. Once we find the one that works, we'll move on. So every ordered pair gives us an x and a y value. We're going to plug that in to our equation, right where it says x and right where it says y. So the y is going to become a negative 15. The x becomes a negative 3, and then we keep this plus 3 here, and we keep this times 4 over here. And now all we have to do is just solve this, simplify it down to a single equation. Negative 15 equals negative 12 plus 3, negative 15 equals negative 9. That one didn't work, so we can cross out A. Let's try it again with B. 15 equals 4 times 3 plus 3. 15 equals 4 times 3 is 12 plus 3. 15 equals 15. There, it did work, so it's got to be B. Then we can check these other ones just out loud. 4 times negative 3 is negative 12 plus 3. Nope, that's not going to be 15. And then 4. Well, that's interesting. Looks like D is the exact same answer. I didn't even catch that. Good thing we went and double checked them. Answers B and D are good answers. I think I intended to put another negative in there on the 15, but both of them are good for that one. So either works. If I ever did that on a test, I'd give you points for either of them. All right. Number 2, identify the point that lies in the line. Same thing, but different equation. I'm going to plug this value in for x, this value in for y. See if I can make it balance. So negative 5 equals 3 times 2 minus 1. Negative 5 equals 6 minus 1. Negative 5 equals positive 5. That looks close, but they're not identical, so this one can't have been our answer. Let's try it with B. So that was with A. Let's try it with B. Does 5 equal 3 times negative 2 minus 1? 5 equals negative 6 minus 1. 5 equals negative 7. Nope, can't have been B either. Let's try it with C. Switch colors. 5 for the y value equals 3 times 2 for the x value minus 1. 5 equals 6 minus 1. 5 equals 5. Yes, this one did work. C is our answer. We'll just try D out loud. 3 times negative 2 is negative 6. Minus 1 is negative 7, not negative 5. So D does not work. Has to be C. All right. 3 asks a similar question in a different way. Find the value of y if 4 comma y is a solution to this equation. So I know that when I plug these numbers in, it's going to make it balance. So why don't I plug in just the number that I have, this 4, in for x, and then I'll solve for y. So I can't, I'll replace the y with a y. It won't change. So it's just y equals 4 times 4. I do replace the 4 with an x, minus 2. And now I can just simplify this, and you'll see when I do that, let's root of 12, 16 minus 2, y equals 14. I've got a value for y. It's in my list of answers, so that's a really good sign that I did it correctly. All right. Similar question, giving you an x value, asking you to solve for y. Let's just do this one. Y equals 5 times negative 5 plus 7. Y equals negative 25 plus 7. And then y equals negative 18. It's in my answer choices. That's a good sign. All right. For these next ones, we're doing something similar to what we did on those first couple of pages. We're using an equation and a table to make a graph. So I just need to plug in these values here, these x values in for x, and then solve for y each time. We'll start with 0. So y equals negative 2x, but I'm replacing the x with a 0, so negative 2 times 0 plus 3. Y equals 0 plus 3. Y equals 3. So 3 goes right there. Let's try it with a 2. Y equals negative 2 times 2 plus 3. Y equals negative 4 plus 3. Y equals negative 1. And we'll try it with a 4. Y equals negative 2 times 4 plus 3. Again, I'm just using this equation, but replacing the x with the x value from here. Y equals negative 8 plus 3. Y equals negative 5. Negative 5 goes right there. All right, let's plot these ordered pairs, 0, 3. So 0, I don't move. 3 goes 3's up, 1, 2, 3. There's that first point. 2, negative 1, I go back to the origin. I go 2 to the right because it's positive, 1 down because the 1 is negative. There's that point. And 4, negative 5. I go over to 4, down 5 units. And I make another point. All right, connect those up with the straight line. And we have filled in the table. Then we found the slope and the y-intercept. No, we haven't done that yet. To find the slope, we got to connect these up with the slope triangle. Pick any 2 points. I'll pick these 2 here. You connect them with the slope triangle. This triangle goes 1, 2, 3, 4. This side's 4, but that because it's going down from left to right, that's a negative 4. And then I go to the right, 1, 2, because that's to the right, that's a positive 2. So my rise over run for the slope equals negative 4 over 2, which just equals negative 2. Y-intercept, that's where this line crosses the y-axis. You can see right there it crosses at what looks to be 3. Check the table. Yes, it is a 3. Y-intercept is 3. All right. Some more checking ordered pairs to see if there's solutions. Let's just do number 1. I'll just do it. My work over here. This is not in slope-intercept form. But that's okay. We plug in the x and the y where they're supposed to go. Negative 8 replaces x wherever it is. So it's going to replace the x right there. This is going to become 2 times negative 8 plus 4 equals negative 6. And now we just see if that balances. Negative 16 plus 4 equals negative 6. No, negative 12 equals negative 6. Not a good answer. Try the next one. Negative 1, negative 4. 2 times negative 1 plus a negative 4 equals negative 6. Negative 2 plus negative 4 equals negative 6. Negative 6 equals negative 6. Yes, that balances. So B must be a good solution. Just try the other ones out loud. 2 times 5 is 10. Plus a negative 16 equals negative 6. Yep, this one actually balances 2. 2 times 9 is 18 plus 1. This one does not equal negative 6 on the other side. So B and C were answers for 1. That means we're going to have multiple answers here as you try 2, 3, and 4. All right, for the following equation, plot the table of values. So the table's already given to us, then find the slope and the y-intercept, then write an equation. So let's plot these points, 0, 2. Go to the origin. I don't move left or right, I just come up to the 2. 2, 3, I go 2 units to the right, 3 units up. 4, 4, that's 4 units right, 4 units up. Connect that up with a straight line. Just about like that. Make it a little better, okay. The slope, let's connect 2 points with a slope triangle. This triangle goes over 2, up 1, so our rise over run is 1 over 2. The y-intercept, I see it crosses right there at 2, so the y-intercept is 2. But now we've learned that slope is our m value, y-intercept is our b value. So if I fill those into y equals mx plus b, I'll get the equation y equals 1/2 x plus 2. Just like that. And that Now we've been able to go from a table to an equation by using a graph. I'll let you try that one there. And I believe this is our last page. Yep. All right. The dental insurance plan will cost a flat rate of $140 per year. If I hear flat rate, that makes me think that that's my B value, $140 per year just to have the plan. Plus $20 whenever you have to see the dentist. When I see this whenever, this is like a per time cost. And so since this changes, since the number of times we see the dentist can change, this is our coefficient of how much that change impacts our total cost. So that's got to be our M value. And those are the only two values we need. We can write an equation now with that. And it's going to have us do that down there. I think first just wants us to graph this information. So we got to pick a reasonable scale. Also, we have to figure out what is depending on what. So our independent variable, the thing that we get to control, is how often we go to the dentist. So this is the number of times visiting the dentist. And then what depends on that, our Y variable, is the cost, our total cost for the year, and that's going to be in dollars. Now we got to pick a reasonable scale. What would be like the most you would ever go to the dentist in a year? Well, 0 is definitely possible, but what's the most? I mean, 2 or 3 maximum, but maybe we should show enough for up to, 8 or 9 or 10. So I'm going to count by maybe every 3 boxes is a visit. So 0, 1, 1, 2, 3, 2, 2, 3, 3, 4, 5, 6, 7, 8. I think that's a reasonable scale there. I mean, maybe you could go to the dentist 9 times in a year if you're having a lot of work done. So maybe it would be useful to show that. I don't need to show all the way out to like 100 though, because that's just not going to be very useful to anyone looking at this graph. All right, and cost. I see it starts at 140. It's going up by 20s. So if I make a quick table, at 0, I need to show a cost of 140. If I go and see the dentist 10 times in a year, that's going to cost me $200 extra. So I'm up to 340. So I should have this be able to go up to at least 340 on this side. If I counted the boxes, it looks maybe there's about 20 here. So 340 divided by 20 is 17. I want to go to the next nearest whole number. So maybe I'm going to count up by $20 increments. So I'm going to have this be $0 down here, then 20, then 40, 60, 80, 100, 120, 140, 160, 180, 200. Up here's 240, 280, 320, 360, 400. There's a lot of math that goes in just to making this scale work out well, so that we're reviewing a good part of this graph. All right, so if I don't go at all, I still have to pay something. I still got to pay that 140. That's going to be my y-intercept. If I go one time, I got to pay an additional $20. So that's just one box. That takes me up to there. 2 times is an additional box, or $20. We go 3 times, that's an additional $60 on top of that 140. Takes me all the way up to 220. All right, and I can just keep this pattern going of up 1 over 3. But really, I'm going up $20 over one visit, but I've just kind of rescaled it. And I'm just going to leave it as these dots. It doesn't make sense to connect them up because you can't go half a time. So if we want to be accurate with this graph, we should just leave it as dots. But these dots still do follow a linear relationship, so we still can express this relationship with an equation. What is the slope of this line? Well, I can make a slope triangle, but I got to be very careful to count correctly when I do this. This is not up 1 over 3. This is over 1 unit. It only went from 0 to 1, up $20. So 20 over 1 is 20. What does this represent in this situation? That is the cost per visit is $20. It's the slope. We can see it in our graph. We can also see it in the word problem. What's the y-intercept? Well, we can see it crosses the y-axis at 140, which makes sense with the word problem. How does the y-intercept represent the situation? This is the cost of not going at all, but still having the plan. So, you know, it might not sound like a very good deal, but maybe that's what helps motivate you to get to the dentist, is that you have to pay a certain amount anyway, so you might as well go make the most of that money by going to the dentist a few times. Write a linear equation. Well, this is going to be our slope. This is our y-intercept, so y equals 20x plus 140. If you budgeted $500 for your dental costs, how many times can you see the dentist? So 500, that's all the way up here. Can't even see where my line's going to cross that. So I'm going to have to solve this algebraically. The 500 is going to go in for y. This is going to create the equation 500 equals 20x plus 140. Take the 140 away from both sides. And I get 360 equals 20x. Divide both sides by 20. And cross down to 0 and just do 16 or 36 divided by 2 and get 18 equals x. Let's give that a unit. 18 visits in a year. That's a lot of times going to the dentist. All right, that's that for this video. Hope you have a good rest of your day.